This video goes along with page 4 of the 2.2 Histograms guided notes, and it reviews how to make a frequency distribution and a histogram on paper and on our graphing calculator. It reads, Professor Hill in the music department kept a list of the number of students visiting his office each week for 30 weeks. You can see the 30 pieces of data right here. We're going to make a frequency table with 6 classes showing class limits, boundaries, class midpoints frequencies, relative frequencies, and cumulative frequencies. I want to remind you that if you're just asked to make a regular old frequency distribution, it just includes class and frequency, which I have boxed right here. If you were doing a relative frequency distribution, you'd have the class and the relative frequency. You can see that midpoint and boundaries are listed here to the side. Those are extra, and they're going to help us if we had to make a histogram in our graphing calculator. And also, we'll see to the right the class and the cumulative frequency, and we'll be doing that distribution as well. Our first step when we're making a frequency distribution is we need to determine the class width. And since we are going to have 6 classes, what we'll do is we'll take our maximum of the data and we'll subtract our minimum of the data to get the range, and we're going to divide by our desired number of classes, 6. We can see our maximum data value is 32 and our minimum is 3. So I'm going to do 32 minus 3 divided by 6. And that'll give me 4.83 repeated. I'm going to round that to a nice number I can work with, and that's 5. So we're going to say the class width is 5. Since the lowest number is 3, I'm going to go ahead and use that as the lower limit of my first class. So the lower bound of my first class is 3, and I'm going to add the class width, which is 5, to get the lower limit of the second class. And I'll keep adding 5 so I have all of the lower limits of the classes. So we'll have 13, 18, 23, and 28 as all of my lower limits for the classes. Now, to get the upper limits, I'm going to think, what is the highest integer that can be in the first class that's lower than the number 8? Well, that would be 7. And all of your upper limits for the classes are a class width of 5 apart. So I can say 7 plus 5 is 12. 12 plus 5 is 17. 17 plus 5 gives me 22. 22 and 5 is 27. And then 27 and 5 will give me 32. So I have my lower and upper limits for my classes. Now we're going to go ahead and tally the data into each class for our frequencies. So 15 is between 13 and 17. 16 is between 13 and 17. 20 is between 18 and 22. Go ahead, pause the video, and finish tallying, and we'll check our answers together. Let's check in. You should have gotten the first class has 7, the second class has 11, third has 5, then we have 2, 3, and 2. When you add all these numbers up, you should get 30 because there were 30 data items. That's our frequency distribution. To get the relative frequencies, we're going to take each number that we got for frequency and divide it by our total of 30. So 7 divided by 30, 11 divided by 30, 5 divided by 30, 2 divided by 30, 3 divided by 30, and 2 divided by 30. Go ahead and put those in your calculator so you can come up with our decimal answers to check together. Relative frequencies are as follows: 0.23, 0.37, 0.17, 0.07, 0.10, and 0.07. When you add those up, you'll notice you'll get a total of 1.01. We should really get 1, but it's off due to rounding, and that's okay. Let's look at our cumulative frequencies now. So for our cumulative frequencies, remember that the classes aren't going to be the same. You need to list the classes and inequalities. So the first class, we're looking for all of the numbers that would come before the second class starts. And the second class starts at 8. So we're looking for x values less than 8 in our table. And that would include the frequency of just 7, what we had in our first class in our regular frequency distribution. Our second cumulative frequency will be all the numbers that came in the first two classes of our regular frequency distribution. So we're looking for all the x values that come before the third class starts at 13. So we'll have to do 7 plus 11 equals 18 in this case. Following suit for the third cumulative class, it's all of the numbers that come before the fourth class starts at 18. So x is less than 18, and we'll take our 18 that we have here and we'll add 5 and we'll get 23. So that's 7 plus 11 plus 5 is 23. And then we'll have x is less than 23 for our next class, and we'll take our 23 that we have from the first three classes, we'll add 2 and we'll get 25. Next, we'll have x is less than 28, and we'll count up the numbers from our first 5 classes listed, and we'll have our 25 that we already have, and we'll add 3 to get 28. And then finally, we'll have x is less than 33, and we'll add all of our numbers together, and we'll get our total of 30. The last cumulative frequency is always going to be the total number of data items. We have now reviewed a regular frequency distribution, a relative frequency distribution, and a cumulative frequency distribution. The next step is for us to make a histogram. We can't make our histogram without finding the boundaries. So we're going to go over on the left here and find the boundaries. Remember, the boundaries, to get them, we're going to take an upper class limit and take the next lower class limit and average them. So between 7 and 8, we'll get 7.5. And that bounds the first class from the second class. And then we'll have between 12 and 13, that will be 12.5. Then we'll have 17.5. And then 22.5. And then 27.5. And you'll notice that I wrote these numbers twice, but that's just to show you that the number 7.5 is an upper bound for the first class and a lower bound for the second class. On your homework, you'll just list each of them once with a comma in between. What I'm missing is the very lowest bound and the very highest bound for our set. So we can follow our class width, and we can just take and subtract from the 7.5, subtract 5, and we'll get a lowest bound of 2.5. We can take from this 27.5 and add 5, and we'll get 32.5 for our highest boundary. Before we make our histogram, we are asked in this exercise to find the midpoints, which we won't need to actually make our histogram, but let's do it just for practice. To find the midpoints, you're finding the midpoints of each class. So what you do to find the midpoint of the class is you take the lower bound of the class plus the upper bound of that class, and you're going to divide it by 2. So first we have 3 plus 7 divided by 2. Well, it's 10 over 2, or 5. You can follow that same pattern, or you can say, well, our class width is also 5. So the midpoints will all be a class width apart. So I'll have 5, 10, 15, 20, 25, and 30 for my midpoints in this case, following that pattern of adding your class width every time. Not only have we created our different types of frequency distributions with this data, we've also found all of the different parts, such as the boundaries and the midpoints. Let's go ahead and make our histogram as well. So to create our histogram, what we're going to do is we're going to make an x and y axis first. Remember, the y-axis is your frequencies. And we can see that our frequencies go from 2 all the way up to our highest number, 11. So I'm going to go from 0 up to 12 on my y-axis. For my x-axis, my horizontal axis, that's where we put our classes and we use our class boundaries. So I'm going to go from 2.5 to 32.5. Now you can see I have my axes labeled. I can go ahead and take my frequencies and fill them in. So the first class went up to 7, so I'll make a bar that goes up to 7. The second class goes to 11. The third class goes to 5. And then we have 2, 3, and 2. We can see we have our frequency distribution. Using the same data, we're going to make a relative frequency distribution. For a relative frequency distribution, we're going to find that it has the same shape, but what's different is our y-axis is going to be labeled differently. What are we going to use to label our y-axis? Well, our relative frequencies. The lowest relative frequency we had was 0.07, and then our highest was 0.37. So our y-axis will go from 0 to at least 0.4. Now that we have our axes written in, we can go ahead and make our graph with our relative frequencies. The first class is at 0.23. The next class is at 0.37. And then we have 0.17, 0.07, 0.1, and 0.07. You can see the shape of our histogram in part B and our relative histogram in part C are exactly the same. The only difference that we see is the labeling along the y-axis for relative and for regular. You can also see that each have that shape of being skewed to the right. As a final thing for this example, I would like to take our graphing calculators and show you how to make a histogram in your calculator given just a set of data like we have for these 30 data items. In your graphing calculator, go Stat, press Enter on Edit, and what you're going to do is you're going to clear whatever you have in your list 1. So highlight the list, press Clear, Enter, and then you're going to type in each data item that you see here. So you'll start with the number 15, press Enter, and continue until you have all 30 items in your list. Pause the video to make sure that you have all of the data in your list. Once you have it in, go through and check to make sure the numbers are correct and that there are 30 data items. Now, once your data is in, you're going to press second y equals to get to stat plot. Select the first stat plot. Make sure on is highlighted. Press enter on to make sure that you have your stat plot on. Scroll down to type and then to the right until you get to histogram and press enter. We put our data in list 1. If you used a different list, you'll make sure the list you used is right there. But to type in list 1, I would press second and then the number 1. We did not use frequencies. You might have list 2 or some other list listed in your frequency, but since we didn't use a frequency, you can just type the number 1 there. Color is irrelevant. Use whatever color you want. Whatever makes you happy there. Now press zoom 9 and you should get a frequency distribution histogram that has 1, 2, 3, 4, 5, 6, 7 classes. We can change this class information by going to window. Now our frequency distribution that we made had 1, 2, 3, 4, 5, 6 classes. And our minimum data item that we had used was 3, and we let our data go up to the number 32. So let's let our window reflect that. In our X scale, let's use our class width from our frequency distribution of 5. The minimum value, I like to go below 0 just so when you're looking at data, your x-axis isn't cut off. So this is a fine number, and our maximum should be a little bit above whatever our maximum frequency was, which was 11. So 12.87 should be fine. I like to put a nice number in. We'll put 15. And our y-scale doesn't really matter. Now we can press graph, and you should see a frequency distribution that looks similar to what we had. You can see our last class is a little cut off. So I'm going to go back to window and change the X maximum to say 34. And now look at my graph. And you can see that our classes are perfectly and not cut off, just as they should be.